Welcome to Data Science with EJD. In this video, we're still talking about validation and tuning in supervised learning. And our focus here, I mentioned in one of the previous videos something about data leakage. It's something that we want to be careful about in machine learning tasks. So our learning objective and goal here will be to understand and prevent data leakage by isolating training and test transformations. So you don't want training set to leak into test set, and you don't want test set to leak into training set. Of course, we know that for cross validation, right? You have five partitions and you have these things changing over, but that's still but in all, you just want to be sure that at any point in time, the test set don't become training and training don't become test or something. Then the next thing is want to recognize and simulate and eliminate data leakage in machine learning workflow. So the question is, what is data leakage? So data leakage occurs when information from outside the training data set is used to build a model. It's not in the training data set, but it comes in to build a model. So it's going to give some bias. So this leading to unrealistically high performance during evaluation and poor generalization in real world applications. So that's the idea of data leakage. So you have more on some data not outside of the training set used for training the model and then giving wrong results. Then there are different types of data leakage. So you have pre-processing leakage. So here you have things like scaling or encoding using full data before train test split. So if you scale or encode using full data before train test split, that's going to be wrong. For instance, I mean the idea of scaling is, it's for the whole data set, right? You don't want to scale or encode the whole data set before you train, right? Uh before you split up. So you do this after splitting. So you do the scaling and encoding after you have split. Then there's also target leakage, which including future or label derived information in training features. So what you are going to use later, you are already using it in training the model. Then there's temporal leakage. So in this case, you are using future data to predict the past in time series. Okay, that's temporal leakage. Then there's cross-validation leakage where you are applying transformations outside the cross-validation loop. And there's manual feature engineering. So here you are creating features from the full data set that reference the test data. So these are some possibilities of leakage. So best practices to prevent leakage will include split first. Okay, always perform train test splits before any transformation. And then the next is train only transformation. So you fit scalars and encoders only on training data. Then you can now transform, then you can transform the test data, you know. Then use pipelines. So here you automate preprocessing to be applied safely and consistently. So you don't forget, especially if you are deploying this every time. Then avoid data leakage, avoid target leakage rather. In this case, don't use future or outcome related data in input features. Then respect time order. For time series, avoid shuffling and use time series split or similar methods. So this should be paid attention to. So let's look at a hand-on task where we simulate and fix data leakage. So we'll demonstrate data leakage using the breast cancer dataset, then correct it and finally use a pipeline, right? So first, load dataset as usual. So from scikit-learn dataset, import load breast cancer, which we want to use, then import pandas as PD for some, you want to create data frames and all that. So load breast cancer dataset. So data is load underscore breast underscore cancer, open and close brackets. So an X is PD data frame, data.data columns, data.feature names. And then Y is target data. So you run this. Okay, now it's done. And then here, I just want to see what X looks like. So I have control, so shift enter. So we have things like mean radius, mean texture, mean perimeter, mean area, mean smoothness, mean compactness, mean concavity, mean concave point, mean symmetry, mean fractal dimension, worst radius, and things like that. You have a whole lot of information in the breast cancer data set. I think these are measurements for the breast. So you also want to see the so those are the features now. So there you see we have 569 rows and 30 columns. So we have 30 features in all, and then we have one target. So you have the targets. So I want to believe that this target is about whether, based on those measurements, there's cancer or no cancer in the breast. Basically, I believe that should be it. Then talking about, so now in step two, now we are going to see how we can have a leaky workflow, a workflow where we have data leakage, which is actually incorrect. So we mistakenly scale the entire data set before splitting. That's a classic data leakage case. That's scaling the entire data set before you split up. So here we need, from pre-processing, we need standard scalar. From model selection, we need train test split. Then from linear model, we need logistic regression. From metrics, we need accuracy score. So here you have imagine scalar. The scalar is coming in already. So standard scalar. So you are scaling before splitting. So x scaled now will now be scalar dot fit transform x. So there's automatic leakage here because here you are including test data information, which shouldn't be. So you shouldn't include test data information at this point. Then after that, so you already scaled before you now split. So that's you committing the data leakage error. Then you now train and evaluate the model. I mean, you still get a result. In fact, the result might even be very excellent for that matter. So since you're using logistic regression, so your model is logistic regression with 10,000 maximum iterations, then you feed the model, then you predict straight. So train, feed, and uh, 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 of course, the fit is the training, right? And then you predict. Then afterwards, you evaluate. Then we now want to see the accuracy for this now. So we press this, and that is excellent. 0.9736, blah blah blah. So that's like 0.97 to two decimal places. So the accuracy is most likely inflated due to training on information from the test sets. Okay. So scaling before splitting will lead to data leakage. So how do we take care of this? In step three, now we correct the workflow where we ensure that there is no leakage. So we now correctly isolate preprocessing into the training set. Okay, so the right split. So you split up first. So right split, you have X train, X test, Y train, Y test, and do the splitting first of all. And then you can have do fit scalar on training data only. So you have scalar, standard scalar. So X train scaled, you have scalar dot fit transform X train. So because we're seeing the train sets as mutually independent of the test set. So you have to scale them separately. So scaling means you're making the data set into a normally distributed data. So you don't want to do it overall. You want to do for train separately. So the train set is normally distributed while the test set is also normally distributed. But if you do it all together and now split, it means none of them will be normally distributed anymore because you have scaled before splitting. So and that is the idea of data leakage. Then you can now that you have done this, then you do the normal things of train the model and evaluate and make a prediction. Then you evaluate the model. So here we press enter, and then the result is about the same. Probably the data set is so easy to work with, but I mean the fact that the result is the same, it does not mean that it's nice to scale first before splitting. So in most situations you have different results, right? So here normally the result is the same, right? But usually when you do the right thing, you expect the result to be slightly lower but more honest accuracy, which is a better generalization. So in this case it's not like that, but in most cases you can expect that when you split before scaling, you get a result maybe not as good as when you scale before splitting, but then this slightly lower result is more accurate and better, more reliable because you have actually split before scaling, right? So what we can now do is we can now do an ideal workflow with pipeline. So in the previous video, we had seen the idea of pipeline. That's you trying to automate some processes so you don't forget. So we use pipeline to automate and protect the processing process. So you have from sklearn, scikit-learn.pipeline imports pipeline. So create pipeline. So you have pipeline is this. So you do the scalar, you do the classifier, which is logistic regression in this case with 10,000 maximum iterations. Then you can now resplit raw data. So you split first and then you just do it with the pipeline. So in this case now, you don't have to worry about scaling or anything because the pipeline already has scaling embedded into it. So you just fit and predict. So you have pipeline.fit x train y train y pred. You have pipeline.predict. So this way, all of that is automatically done. So you don't have to worry so much because pipeline is in charge already. So you run this now and you can now be sure of, in this case all the results are the same, but you can be sure that here the result it will just be like when the most accurate one. Although the leaky, where we had data leakage, we still have about the same result, probably because the data set is not is so easy and not so complicated, so to speak. But of course you want to, I think the fundamental rule is split before scaling, basically. Split before preprocessing, not preprocess before splitting, right? So this here ensures transformations happen only on training data and keeps your workflow clean and safe. In the summary table, we have the leaky workflow. Uh, Scalar is applied before split, and there's data leakage for sure. The accuracy results will be overestimated. It will be very high, most likely, but it is overestimated. It's not that reliable. Then the workflow manual save. So in this case, you have after split manual. That is, you split and then you scale. So data leakage, no, and it's reliable. Then pipeline safe, automated inside fit. So automatically you already have scaling and all that as in your pipeline already. So there will be no data leakage. And in that case, this is reliable and maintainable. So because it's more like automated, so there's no problem about forgetting. Okay, so let's talk about some reflective practice. Now you can try to go back to a previous project, maybe a classification, regression, or natural language or time series project. Check, did you apply any preprocessing before splitting data? That's very possible. I think it might even be possible in some of the videos I've made previously that I actually preprocessed before splitting or so. So you may want to check and let me know about that, right? So if yes, you need to refactor. So use train test split or cross validation before transformation. Okay, then you now use pipeline or column transformer to manage preprocessing safely. So we have a bonus cross validation without leakage now. So what we did was train test split. So but we can also do cross validation, without leakage. So use cross val score with a pipeline to avoid leakage during cross validation. So from scikit-learn model score selection, you bring cross val score, and you have your pipeline, scalar, classifier, logistic regression, and all that. So now the scores, score val score. Then here you bring pipeline into it. So that automatically takes care of the whole idea of pre-processing and all this, and then you can just print CV accuracy with no leakage, and that is 0.98, which is better than whatever we've done before. Of course, we know generally that cross validation gives better results than train test split. So some key takeaways from this is that we never use information from the test set in training, even accidentally, because if that happens, you're going to have data leakage. Then next, you always split first, then transform, not transform, then split. Then use pipelines to protect against future mistakes. So that's a way of, already making sure that you don't get into the trouble of mistakenly forgetting to split first before you transform. Okay, then leakage is when you have leakages like that, it will give you unrealistic model and poor generalization. So, such an interesting one so far, and we've come to the end of that. Let me know how helpful this is for you. Uh, let me also know if there's something you like want to try out. If you have subscribed to the channel, thank you for doing that already. If you have not, be sure to do that right away and hit the notification bell so you can always get alerted each time a new video is released. Consider being a member of the channel, and that way you can get some special privileges. Of course, if all you do is subscribe, you are good to go. You still have access to most of the videos on the channel, but as a member, you get some extra privileges for sure. Like and share this video and all the other videos so that more people can have access to this great content I have going on here. Till I come your way again, keep doing data right. Bye.